If you were to count every single grain of sand on every beach on Earth, you still wouldn't come close to the number of stars in the observable universe. Astronomers estimate there are around 70 sextillion of them. Given those numbers, basic probability dictates the cosmos should be overflowing with life. Even if only a tiny fraction of those stars host habitable worlds, the sheer math suggests ancient, galaxy-spanning civilizations should be everywhere. And yet, when we point our most sensitive instruments at the sky, we hear absolutely nothing. In 1950, physicist Enrico Fermi was walking to lunch with colleagues at the Los Alamos National Laboratory when he brought up this exact problem. He asked a simple question: where is everybody? He had identified a severe mathematical anomaly. The scale of the cosmos transforms an empty sky into a terrifying existential paradox. The most common defense for the silence is distance. Space is notoriously vast, and crossing it seems impossible. But as this map demonstrates, a civilization with technology only slightly more advanced than ours could colonize the entire Milky Way in just 5 to 50 million years. That sounds like an eternity, but within the universe's 13.8 billion year history, that expansion is instantaneous. Many stars in our galaxy are billions of years older than our sun. That gives any potential extraterrestrial life a massive evolutionary head start to make that galactic journey. If they had that kind of time, we should see the physical evidence. We should be detecting automated mining probes in our own solar system, or observing massive engineering projects blocking out the light of distant stars. We see no probes and no structures. This complete absence of activity suggests a lack of time is not what keeps the galaxy empty. To figure out exactly where the universe is breaking down, scientists use a probabilistic argument known as the Drake equation to systematically run the numbers on intelligent life. For decades, astronomical models operated on the assumption that Earth-like habitable planets were a cosmic rarity. Then, advanced space telescopes began identifying exoplanets by the thousands, proving that rocky worlds are not the exception but the rule. This visual tally illustrates the current estimate. There could be up to 40 billion Earth-sized planets orbiting within the habitable zones of their stars in the Milky Way alone. Prime planetary real estate is abundant. Because it is completely vacant, the absence of aliens must be caused by a much deadlier bottleneck further down the line. With the rare planet hypothesis eliminated, the burden of explanation shifts away from astronomy and moves towards biology and sociology. The first potential biological bottleneck is the origin of life itself. It is possible that dead chemistry sparking into simple, single-celled organisms is an incredibly rare miracle. The second evolutionary bottleneck occurs later. Simple life might exist everywhere, but the leap to multicellular complexity and the development of intelligence could be nearly impossible. The third possibility is sociological. Intelligent species might emerge frequently, only to develop technology that universally wipes them out. Researchers point to specific mechanisms for this, ranging from rogue nanotechnology escaping containment to a civilization triggering nuclear annihilation shortly after discovering radio communication. The math suggests an invisible bottleneck prevents technological life from expanding beyond its home world. This concept is known as the Great Filter. It proposes an evolutionary barrier so incredibly difficult to overcome that it eliminates almost every species that encounters it. Looking at this evolutionary staircase, there are two ways to frame this barrier. In the first scenario, the massive wall of the Great Filter is already behind us in our evolutionary past. If the filter is behind us, it means humanity achieved a 1 in a quintillion biological miracle, making us the cosmic exception. While being the only survivors in a dead galaxy might be lonely, it suggests the greatest threat to our survival has already been beaten. Then there is the second scenario. The Great Filter is still ahead of us. Under this framework, discovering any form of extraterrestrial life suggests that the barrier to survival still lies in our future. Imagine a NASA announcement tomorrow that they found fossilized bacteria on Mars, or ancient ruined structures beneath the ice of Titan. If life starts easily on multiple planets in a single system, the origin of life cannot be the Great Filter. If the universe is highly efficient at creating civilizations, then a universal barrier is highly efficient at ending them before they leave their stars. Finding life out there would mean the timer is already counting down for us, waiting for the thing that keeps the galaxy quiet. Data from the Kepler Space Telescope indicates there could be up to 40 billion Earth-sized planets orbiting in the habitable zones of stars, right here in our own Milky Way. By the numbers, our galaxy should be humming with the signals of countless alien civilizations. Yet every time we point a radio telescope at the sky, we hear absolutely nothing. Many of those star systems have been around for billions of years longer than our own. That is more than enough time for a species to develop space travel and spread across the galaxy. So, as physicist Enrico Fermi famously asked, where is everybody? This lack of contact suggests a universal mechanism exists that systematically wipes out intelligent life before it can make itself known. We can think of the development of life as a staircase. You start with dead chemistry at the bottom, step up to single cells, complex brains, and finally a galaxy-spanning civilization at the top. Since space appears completely dead, there must be a nearly impossible step on this staircase that stops almost every species in its tracks. Scientists call this the Great Filter. This leaves two scenarios. Either the filter is behind us, and the emergence of life is so incredibly rare that we are alone, or the filter is ahead of us, waiting to wipe us out. This is why finding signs of life on another planet, even simple bacteria or ancient fossils, would be devastating news. Looking closely at the barren red dirt of Mars, our best hope for human survival is that this planet and the rest of our solar system remains entirely sterile. If complex life is common in the universe, it means getting past the early evolutionary steps is incredibly easy. That implies the Great Filter is still waiting for us in our future. Astronomer Carl Sagan suspected the answer lies in the Drake equation, specifically its final variable, L, the length of time a civilization can actually survive once it develops advanced technology. The very traits required for a species to dominate its home planet, ruthless competition, aggressive resource extraction, and rapid expansion, become immense liabilities once that species invents high-tech weaponry. A powerful civilization can easily trigger its own extinction. This could look like runaway climate collapse, the genetic engineering of a lethal superbug, or a super-intelligent AI that destroys its creators. We already possess the tools to accomplish this. The development of atomic weapons proved that a single species can wipe out its own planet in the span of an afternoon. Developing the technology needed to communicate across the stars might universally act as the trigger for a species to destroy itself. That suppose a civilization manages to overcome its own destructive nature, why is the sky still silent? Another explanation proposes that the galaxy is actually full of advanced life, but they are all intentionally hiding. This is known as the dark forest hypothesis. In a universe where you cannot verify the intentions of a distant alien species, and where weapons can travel at a fraction of light speed, the safest move is to destroy any civilization the moment you detect them. Under this logic, the cosmic silence represents a galaxy of hunters, and any civilization foolish enough to reveal its location is swiftly eliminated. If the universe operates as a dark forest, humanity is ignoring the rules of survival entirely. We are completely exposed. Rather than hiding, we actively try to alert the universe to our presence. We have spent decades beaming highly targeted radio signals directly at distant star clusters. Even if we stopped sending deliberate messages, our day-to-day operations betray us. The glow of our city lights and the swarm of satellites in our orbit act as glaring technosignatures to anyone watching. Furthermore, we orbit a bright, stable G-type star. Any advanced civilization conducting a systematic survey of the galaxy would flag our solar system as a prime target for investigation. We are climbing the evolutionary staircase at a blinding pace, developing more powerful technologies every year, without knowing what waits for us at the top. We are shouting into the void of a pitch-black forest, where the true horror comes from the possibility that something is listening.